So welcome to this latest video on 162 Maths, and in this video we'll be going over the AS Maths Mechanics topic of Forces 1, an introduction to forces, and focusing on Newton's first law of motion. So what is a force? A force is something that causes an object to change speed or direction or shape. There are two types of forces. There are contact forces and there are non-contact forces. A contact force is a force that acts on an object only when there is physical contact between it and another object. It's usually a push or a pull that requires direct interaction. Now, examples of contact forces are a driving force. So driving force when a car is moving forward is when an external force that causes a system to change from its equilibrium state, in other words, its resting state, to initiate motion or flow. Now, friction is a force that opposes the motion of an object when its surface rubs against another surface. Tension is either by a rope, string or a tow bar, and it's the force that's moving away from a connection, so again often by a rope, string or a bar. We've also got thrust. Now, thrust is a force that moves an object forward generated by propulsion system that expels mass in the opposite direction, so it relates to Newton's third law. A normal reaction. Now, a normal reaction is a supportive force exerted by a surface on an object in contact with it, acting perpendicular to the surface. Reaction to an object pushing on a surface prevents the object from penetrating the surface. So in other words, it's the force that keeps things level. So here we've got a person standing, so the actual natural reaction will be the force that the floor puts on to the person to prevent the person from going into the ground, and so that there will be our natural reaction. Next we have buoyancy. Now, buoyancy is an upward force exerted by a fluid that opposes the weight of an object submerged in it, determining whether the object will float or sink. So when an object is in liquid or fluid, it's the buoyancy force that will basically dictate whether it's either going to float or whether it's going to sink. Now, in terms of non-contact forces, a non-contact force is a force that acts between two objects without physical contact, operating through a field. Now, examples of non-contact forces are commonly gravity, electrical and magnetic fields. Now, in terms of electrical and magnetic, they tend to be more taught in physics. And in terms of the units of force, so force is measured in newtons, and 1 newton is the force required to accelerate 1 kilogram by 1 meters per second squared. So now let's have a look at some example of forces. So if we take the example of some books resting on a table, let's see what forces are in play here. Now, in terms of this, we have a force going down, which is going to be our weight of the books, or we could say it's the force of gravity that's putting those books down. Now, in terms of the weight of the book, weight is equal to mass times gravity, and that is a really important formula that's worth remembering. So it's the force that's going down is equal to, so weight is equal to mg, and we also have a force that's going up, which is our reaction force. Now, a reaction force, or our normal reaction force, is the force that is preventing those books from going through the table. So these are prime examples of vertical forces. So either something's going to be hanging, or it's just going to be lying on a sort of flat surface. Now, when you've got something that's hanging, you've got resistance force or tension, which is moving it up, and you also have the weight, which again is equal to mass times gravity, pulling the weight down. Now, when you have got something on a flat surface, then you have got the normal reaction, which is the force that is preventing the object from going through, and you've also got the weight of the object lying on the surface. Now, if we have a look at horizontal forces, and in particular as an example we take a car that is travelling forward, then the forward force is going to be the driving force or the tension going in the same direction as the car, and the forces acting against the car are going to be our braking force, friction and air resistance, which can all be grouped as our total resistance force. Now, you will be told if these are a factor. You will just be told about the driving force and the resistant force in not great detail. So always make sure you read the question carefully, but generally speaking, you'll either be told that these are a factor. If not, you can kind of ignore these factors. So now let's have a look at some example questions. So question 1 says a suitcase has a mass of 18 kilograms. What is its weight in newtons on Earth where gravity is 9.81? So for this, we're using the formulas that weight is equal to mass times gravity, and this is a formula that you're not going to be given, so it's one that you need to learn. So using this formula for question 1, we have mass, which is 18, gravity, which is 9.81. So to work out the weight, I just multiply those two numbers out, and if I type that into my calculator, I get an answer of 176.58 newtons. Then for question 2, it says an astronaut's equipment weighs 184 newtons on planet Earth where gravity is 9.2 meters per second squared. What is the mass of the equipment? So again, for number 2, we're looking at the weight is 184 newtons and gravity this time is 9.2. So again, worth checking. They will tell you in the question what value of gravity to use, or it will be given to you on the front of your exam paper. But for this, all we then need to do is to work out the mass is do 184 divided by 9.2, and on the calculator that gives us an answer of 20 kilograms. So now let's have a look at resultant force. So the resultant force is the overall force acting on an object. An object will accelerate in the direction of the resultant force. So for example, if we take two people that are pulling in opposite directions on a rope, then if A pulls harder, then the resultant force will be by the difference in the force and in the direction of A. If B pulls harder, then resultant force will be by the difference in force and in the direction of B. And if A and B both pull with the same force, they both will not move and be in a stationary motion, or what we call an equilibrium. Now the word equilibrium is really important that you make a note of, and that is when you have both forces pulling in all kinds of directions at the same force. Now it's worth noting that commonly in regards to mechanics question, a question will either give you A and B and ask you to find the resultant force, or they will give you A and the resultant force and you have to find the force of B, or they will give you B and the resultant force and you need to find A. So let's have a look at some example questions. So question 1 says state the magnitude and direction of the resultant force. So here we have two forces acting upwards and one going down. So for this, if we look at the total going up, that's going to be a total of 34. And the total going down is 27. So in terms of the difference, it's going to be 34 minus 27, which gives us an answer of 6 newtons. Now we then need to state the direction, so it's 6 newtons up, or you can write it as a vector of 0, 6. And again, what you can then do is write this as 0i plus 6j, should you want to use more vector notation. Now let's have a look at the second question. It says state the magnitude and direction of the resultant force. So here we've got a total of 8 plus 13, which is going to give me an answer of 21 newtons, and going in the opposite direction we have 17 newtons. So in terms of which direction it's going to go, the answer is going to be 4 newtons going towards the right. So I can either write that, or I can write it as a vector, which is going to be 4, 0, or I can write it in more vector notation of 4j plus 0, or 4i I should say, plus 0j. Now the key thing to remember that is if several forces act on an object, then we get a resultant force. So in these particular 6 examples, we're asked to find the resultant force in each case. So if you want to have a go at these questions without going through the answers, feel free to pause the video, have a go at the questions, and then unpause as we go through the answers. So looking at this first one then, so we can start by actually labelling it as 1. And what we have is got 8 newtons going to the left and 26 going to the right. So what we then have is a case of it going this way by a total of, and that's going to be 18 newtons. So again, we can either write it as 18 newtons to the right, in which it's this particular diagram. Now in these particular questions, if it's a worded question, then it'll be really difficult to state what's right, what's left, and sometimes that can be represented by negative answers or positive answers. It really does depend on what the directions are. If something is going to the left, then something negative, so that will be deemed as going positive, but then if it's any force going backwards against it, will be classed as negative. So signs really isn't that important when it comes to these particular questions. Obviously if you've been given a diagram, then it's quite easy for you to state those, but if you haven't been given a diagram, it's something certainly that's worth looking out for. So going back to question 1, we can state that it's 18 newtons to the right, or we can write it as 18i plus 0j. For number 2, we've got a total of 13 plus 8, which is going to give me an answer of 21 newtons, and we've got 17 newtons going in this direction. So then that's going to be plus 3 going here. So I can either write 3 newtons to the right, or I can write it as 3i plus 0j. For number 3, we've got a total of plus, and that's going to be 14 newtons going up and 14 newtons going down. So this is going to be at an equilibrium. Oh, if I can spell it. So this is either we can say that this is going to stay still, or we can say it's going to be stationary, or we can say it's at an equilibrium. Like so. So any of those would be absolutely fine, but the proper terminology would be equilibrium. Then for number 4, we've got a total of 15 newtons going up and 18 newtons going down. So this is going to have a total of 3 newtons down, or we can write this as 0i minus 3j. Then for number 5, we've got a total of 19 newtons going to the right, 19 newtons to the left. So this is going to be at an equilibrium, or stationary. And then for our last example here, we've got a total of 19 newtons there and 26 newtons going to the right. So it's going to be going to the right with a difference of 7 newtons, and again we can write this as a vector of 7i minus or plus 0j. So now let's have a look at a worded problem. So this question says 3 forces are acting on an object as shown in the diagram, and the question is asking us to find the magnitude of the resultant force and the angle it makes with the horizontal direction. So with this, what we need to do is, first of all, let's draw our diagram. So for this, we have a little box in the middle. We've got 12 newtons going up. We have 8 newtons going to the left. And if I translate the vector, that's 5 newtons to the right and 8 newtons going down. So in terms of this, what I need to first work out is the resultant force, which if I compare the horizontal motions is going to give me a total of 3 newtons going to the left, and if I compare the vertical motion, I've got 4 newtons going up. So if I have a starting point, I'm going 3 newtons to the left and then 4 newtons up, which means then it's going to be heading in this direction here. Now the question is asking me to work out the magnitude, and the magnitude is equal to the length or the distance. So using my diagram, I know that this distance up is 4 and this distance here is 3, and so what that turns into is a right angle triangle, and notably Pythagoras. So to work out the magnitude, it's going to be, which I'm just going to call m, it's going to be equal to 3 squared plus 4 squared. So m is going to equal 16 plus 9, which is 25, and that's m squared. And so m is going to equal 5. And then from this, which we can call that r, well, we can just write that as m. And then, or whatever you've decided to call it, we'll call it 5. I think that's a better option in terms of the resultant force or the magnitude. And then for B, it's then asking for what is the angle. So if we go back to our diagram, we now know that this is 5, this is 4, and this is 3, and the question is asking us to work out the angle it makes with the horizontal direction. So it's x that I'm trying to find. So this time what we need to do is we need to use trig. So using the original lengths, or whichever you prefer, I'm going to go for the information that's given. So we've got O and we've got A. So this is going to be a tan question. So I've got tan x equals 4 over 3, in which then to work out x, that's going to be the inverse of tan of 4 over 3, which if I type that into my calculator gives me an answer of 53.1 degrees, and that's to 1 decimal place. And one thing just to add is that if they did want me to work out the resultant force, it's going to be 3 newtons to the left and 4 newtons up, which I could easily have written that as a vector, which would have been minus 3i plus 4j. So let's have a look at a second question. So in this question it says state the magnitude and the direction of the resultant force. So for this, the first thing we need to do is establish what the direction is of the resultant force. So here we've got 8 newtons going up, 7 newtons going down, and 8 to the right. So we're looking at going 2 newtons down and 8 newtons to the right. So our resultant force is going to be going in this direction here. So if I was to draw a triangle, we're looking at this, where this is R and we've got our horizontal motions there. Now what I need to do to find the magnitude is to work out the distance. So the magnitude is equal to the distance, in which we've got 8 across and we've got 2 down. and we want to work out what x is. So to work out what x is, that's going to be using Pythagoras again. We've got 2 squared plus 8 squared, and that's going to give me x equals 4 plus 64. So that's going to give me a value of root 68, which I'm going to leave it as a square root. Now the next thing for me then to do is to find the direction. Now for this, what we need to do is we need to find out the angle theta. So what I need to do is I need to work out what this angle here is, as this point here is our equilibrium point. So the direction then is, if I take this triangle out again, I've got 8, I've got 2, and I've just realised that this is, I just worked out that that's going to be root 68. So whichever trig ratio you want to use, I'm going to still always go for the original sort of resultant values. So I've got 8 and 2. So I'm going to be using tan x, or tan theta, equals, let's just change that to a theta, equals, and that's going to be 2 over 8. So theta is going to equal the inverse of tan of a quarter. Now if you wish to use the same values or simplify, it's entirely up to you, in which we get a theta value of, and typing that into my calculator, I get a value of 14.036. So that's going to be 14.0 degrees, and that's to 1 decimal place. So let's look at another question. So in this question, again, we're finding the magnitude and direction, but the only difference with this particular question is that we've been given some vector notation. So let's first of all just start by drawing a particular point, in which case I'm going to draw a little box, and let's have a look at what this notation here says. So looking at that vector notation, it's saying minus 3i, so that's 3 to the left and 6 newtons up. And then with this vector, I'm going 5 newtons to the right and 2 newtons down. Now in terms of the resultant, that's going to give me a total of, looking at the horizontal notion, that's going to give me 2 to the right and going to go 4 up. So in terms of vector notation, it's going to be 2i plus 4j. So that's going to be heading, if we imagine our horizontal line, it's going to be going somewhere in the region of this direction here. So looking at the triangle, if I draw a triangle first, I have my starting point. This is my value of r. It's going 2 to the right and 4 up, as we previously stated, and what I'm trying to work out is what the length of that triangle is going to be. So using Pythagoras again, I get r squared equals 4 squared plus 2 squared. So r is going to equal 16 plus 4, all rooted, so r equals root 20. And then I need to find the angle of this. So to find theta, that's going to be equal to tan theta equals, and it's going to be 4 over 2. So theta equals the inverse of tan of 4 over 2, which gives me an answer of, if I type that in, of 63.4 degrees, and that's to 1 decimal place. So if you feel like you're getting the gist of this, if you want to pause the video, have a go at this question, then unpause the video as we go through the answers, just to see if it's all making sense. And so with this particular question, I always recommend my students to start by drawing a particular point, and then just note down what the vectors, what the directions are in each of the directions. So looking at this, we're going 7 down, and we're going 2 newtons in this direction, and then looking at the vectors, I'm going another 4 newtons this way, and I'm going 3 newtons up. So looking at the horizontal motion, I'm going 6 newtons to the right, and I'm going to be going a total of 4 newtons down. So that can be written as 6i minus 4j. Now, once I've established what the resultant force is, I always recommend doing another diagram in which I'm going 6 newtons in this direction and then 4 down. So overall I'm going in this direction here by r. So to work out the magnitude of finding out the length of r. Now when finding r, I would just simply not bother with using Pythagoras, well actually using Pythagoras, not writing down the steps of Pythagoras, just go that r equals root and then the 2 lengths. So I've got 6 squared plus 4 squared, which gives me an answer of root 52. Then to find out the direction, that's a case of finding out what theta is, in which what I've got is I've got tan theta equals 4 over 6, and again just worth just making sure that you use the right numbers in the right order for this, in which theta equals the inverse tan of 2 over 3, and so theta is going to give me an answer of 33.9 degrees, and that's to 1 decimal place. And there we go. And that leads us to focus on equilibrium. Now, if forces cancel each other out, then the object is said to be in equilibrium. So if we have a look at these two diagrams here, we can see that we've got equal forces going in the opposing direction. So here we've got 19 newtons going here, a total of 19 newtons going to the right, meaning that our resultant force is equal to 0 newtons. And likewise for a vertical motion, we've got a total of 14 newtons going up and 14 newtons down. So then the resultant force is going to be 0 newtons. And so that one of the common questions that get asked is either you are asked to show that the resultant force is in equilibrium, or to find out what one of the forces are after being told that the situation or the object is in equilibrium. Now, when an object is in equilibrium, the object will either be stationary and not move, or be travelling with a constant speed, not accelerating or changing direction, as the forces act on it are cancelling each other out. So, for example, if we have a look at these 3 people that are ice skating, so if this woman was pulling in this direction by 6 newtons, let's say, and this woman was pulling in this direction by 6 newtons, but they're all heading in the same direction. Now, as long as they are traveling at a constant speed, not accelerating or changing direction, then you could say that the woman in red is at an equilibrium. And that leads us on to Newton's first law of motion. Now, with Newton's first law of motion, every object remains in a state of rest or in uniform motion in a straight line unless forces act on it change that state, in which it's kind of represented by this little flow diagram. So if there's no resultant force, there is no change in motion, and if there's no change in motion, you can fairly assume that there is no resultant force. So now let's have a look at a worked example. It says that a particle is subject to 3 forces as shown in the diagram. Given that the particle moves with constant speed, find f of 3 in vector form. So with this, what we know is the fact that it's travelling in constant speed will usually imply that this particle is at an equilibrium, which therefore means that the resultant force is going to be equal to 0. So let's have a look at the three directions. So here we've got one force, we just call this F1, and let's call this one F2. Then what we know is F1 plus F2 plus F3 is going to equal 0. So if I write down those vectors, so F1 is 5, 1, plus F2, which is minus 3, 0, plus F3, which I'm just going to call A and B, they are all going to add up to 0, 0. So from this, what I then know is I know 5 plus minus 3 plus A equals 0. So therefore 2 plus A equals 0, so A is going to equal minus 2, and 1 plus 0 plus B equals 0, so B is going to equal negative 1. So then my final answer in vector form is going to be minus 2, minus 1. So now let's have a look at a similar question. It says that a particle is in equilibrium under the action of three forces, and we've got F1, F2, F3 all written in vector form, and it says the question is asking us to find the values of X and Y. So the fact that it's in equilibrium will mean that the resultant force is equal to 0. So what that therefore means is F1 plus F2 plus F3 is going to equal 0. So writing the vectors, we've got 42x plus y minus 32 plus x over y equals 0, 0. So taking the top line, or the horizontal motion, we've got 40 plus x plus y equals 0, and we've got 2x minus 32 plus y equals 0. Now if I do a bit of rearranging, I get x plus y equals negative 40, and I've got 2x plus y equals 32. And now lo and behold, I've got two equations, two unknowns. So what do I need to use? Simultaneous equations, in which if you enter this on your calculator to solve, in which I'm going to do just that. And if I've done that correctly, I should end up with an answer of x equals 72 and y equals minus 112. So my final answer in vector form is going to be 72 minus 112, or you can write it as 72i minus 112j. In which I didn't do that for the previous question, but again you can write your answer in any of those two forms. And now let's have a look at our third example. It says the diagram shows a particle in equilibrium and under the action of four forces, find the values of A and B. So here again, the fact that it's in equilibrium means that the resultant force is equal to 0. Now again, a couple of ways in which you can do this. You can either call this F1, F2, F3, F4, and what we need to do is we need to find the values of A and B. So we know that all those forces added together need to add up to 1. So what we then have is minus B2 plus 2A plus 16, 0 plus minus A minus B equals 0, 0. So from this, what we then know is minus B plus 2 plus 16 minus A equals 0. And neatening all of that up and taking to the other side, we end up with minus A minus B equals negative 18. And so that's one equation. And if we then do 2 plus A plus 0 minus b equals 0, I end up with a minus b equals -2. So that's my second equation. And then again, using simultaneous equations and using our calculator, we can then hopefully get an answer to this particular question. So I've got minus 1a minus 1b, and that equals -18, and 1x plus minus b equals -2. And again, just make sure that you're using the right substitutions for x and a. So in this particular question, I'm using a equals x and b equals y. So just a little reminder, because you don't want to be writing different letters when you come to this question, in which what we end up with is an a value of 8 and a b value of 10. So our final answer is 8, 10, or I can write it as 8i plus 10j. So then moving on to our last example, it says two people are trying to move a heavy box lying at rest on the carpet. They use two light unextendable ropes. The tension in the ropes are 32i plus 12j newtons and 25i minus 18j newtons. The box remains at rest. Find the magnitude of the frictional force. So the fact that it's at rest and it remains at rest will therefore imply that it is at equilibrium, which means then the resultant force is going to equal 0. So if I just draw a little sketch of this box, now 32i plus 12j, well 32i is going in this direction by 32 newtons and it's going up by 12 newtons. Then if I look at the second one, I'm going a further 25 newtons to the right, but this time I'm also going 18 newtons down. Now for it to be equilibrium, I need to have it so that it's balanced. So here the total resultant force is going to be 57 going in this direction and a total of 6 newtons going down. So therefore the frictional force is going to be countering that, so it's going to be minus 57 and positive 6, in which I can write this as minus 57i plus 6j. So any of those two would be absolutely fine for that. Then it's a case of finding the magnitude. Now to find the magnitude, that's basically the distance of the opposing force. So finding the magnitude, and if you think back to earlier in the video when we looked at questions involving the magnitude, if I have my object, and again going through this, we're going 57 in this direction, and then I'm going 6 up from there, and what I'm wanting is, so the frictional force is heading in this direction and by that force, and it's x that I'm wanting to work out. So to find the magnitude, I need to use Pythagoras, so it's going to be 6 squared plus 57 squared, all square rooted, and if I type that into my calculator, I get an answer. And again, it's always best, I would say, to leave your answer in surds. So I get root 3285. Then it's just a case of checking, does that simplify? No, it doesn't. Oh, actually it does. So I can write it as 3 root 365. Don't know why I've done that. So let me just correct that. So personally, I would say leave your answer like this, but if you wanted to, you can write your answer like that as well. And there we go.